Rule to roster means they will be given in a sentence. You are going to write it in a separated commas, the elements, isn't it? The set, as always, dear students, set is represented by the capital letters, okay? Set of all natural numbers will start from 1. So they cannot be natural numbers lesser than 0. That is going to be known as the null set. 10, 6, 8 are nothing but it is a even number. But what is this? These are letter mixed everything. So this cannot be a set. Hello dear students, a warm welcome to one and all. My name is Vibha, Mathematics faculty at Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. So in today's session, we are going to learn the chapter number 2 in your NCERT textbook, which is nothing but sets, relations and functions. Okay, this is very important chapter. In day-to-day life also you are going to use this, how the sets are used in day-to-day life. For example, if you go to a mall, there will be a set of only the cosmetics. There will be a set of only the clothes. In the clothes also there will be a different sets of the modern clothes, western and then traditional clothes, like that the arrangement you are going to see. So that we are going to use these sets. Where the relations will come part? Relations will come part, for example, in day-to-day life. If you want to celebrate any functions also will be coming under. If you want to celebrate any functions, you are going to invite the relatives, isn't it? So by even order you are going to invite the relatives. So that we are going to use relations, okay? And in maths also we are going to relate the elements of the set. So what do you mean by a set? Then we are going to have it as here. So set is nothing but now what are all the topics we are going to learn under this session? We are going to see now the topics are nothing but we are going to have introduction about the sets, relations and functions, and then you are going to have definition of a set and then methods of describing a set, and then very important is nothing but types of sets, okay? So introduction means you are going to have what do you mean by a set there, okay? So set is nothing but here, see, a set is a collection of well-defined object. You are going to have set of clothes, that too especially modern clothes, or set of books arranged in a school bag, or set of books arranged in a college bag. You are going to have, that is going to be called as, what are all the books? Books are nothing but the elements. So we are going to have it as set. A set is a well-defined collection of a distinct objects. You are going to have it as objects are also going to be known as elements, okay? And also you are going to be known as the member. Okay, each member means each element we are going to name it as what? The member of the family or element of the family. Understood? How we are going to define or how we are going to give an example of a set. For example, the set of boys in a class 11th of basic mathematics, the set of girls in 11th of basic mathematics, and then you are going to have the set of even natural numbers. What are the even natural numbers? You are going to have 2, 4, 6, 8, etc. These are going to be known as even natural numbers. Even numbers means what? The number which is divisible by 2 is going to be known as the even number, isn't it? Next we'll be moving on to the example, the set of days in a week. Of a week 4 you can have, okay? And then you're going to have the set of vowels in the English alphabet. The set of vowels is nothing but A, E, I, O, U. Particularly this is a set, okay? Only this elements you are going to have under set of vowels, isn't it? You are going to have it as. So next we'll be moving on to the example or the problem. Which of the following are sets? See, 4, 8, 12. Obviously, this is a set because it is a multiples of 4. 4 ones are 4, 4 twos are 8, 4 threes are 12. It will continue like that. So therefore, this is well defined, isn't it? So this is a set. This is a set we are going to have. It is well defined. Now 10, 6, 8 a.m. What is this? 10, 6, 8. 10, 6, 8 are nothing but it is a even number. But what is this? These are letter mixed everything. So this cannot be a set. It should be a well defined. That should be there in your mind. It should be well defined. It should have meaning if you want to define that one. So it does not have any meaning because there are numbers also, there are alphabets also. Therefore, this is not a set. This is not a set. and then you are going to have all good films. How you are going to know as that is a set? Because this year you may be having some films are good, next year you may having some films are bad, or some films are good. So it depends on the persons how he is going to accept that is a good film or a bad film, and each person thinking will be unique, it will be different, isn't it? Therefore we cannot accept that all good films will be having the same person's that means same person's wish he is going to like it as. No, never. A person will be a different, he is going to like it as. I may say it as one film will be a good, you may say it as the other film will be a good film. If you think it as a good film, I may think it as a bad, so it cannot be given as a set. Therefore this is not a set. This is not a set. I think you are getting an idea what do you mean by a set and what do you mean by a non-set. Non-set means well defined, it should be acceptable, okay? And then all interesting subject. How you can say it is a set? It cannot be. Why? All interesting subject means I may like mathematics. Obviously, I am a math teacher. I will be liking mathematics. I would not like biology. You may like biology. You may not like maths, isn't it? So that is, so interesting subject can be differ. So therefore, this is cannot be a set. This is not a set, isn't it so dears? Next, so students of a particular college, obviously if you are asking which college you are studying particularly, you are going to say the same college which is nothing but the Vidhyaashram, isn't it? So if I am going to ask it as which college you are working, obviously I'll say Vidhyaashram, isn't it? I cannot change the college as I am working in as. So therefore this can be a set, you are going to have it as. So this is a set. This is a set. Understood? So by these examples you can say which is a set and which is a non-set. Understood? We will be moving on to the next methods of describing a set. What are all the two methods you are having describing a set? One is nothing but you are going to have roster form, or you are going to name that one as a tabular form. And next one is nothing but you are going to known as a set builder form, or the name is nothing but rule form. They may given a roster form and they may ask you to convert it to rule form. They may be given a rule form, they may ask you to convert to the roster form, or ulta also tabular to set builder to tabular. Roster to tabular to rule to tabular, set builder to roster to set builder form. So this they may ask you. Then what do you mean by this, ma'am? Roster form or the tabular form, and set builder form or the rule form? Let us look into the definition, dears. So here roster form is also known as the tabular form. This you have to know. So in this roster form, we are going to have all the elements are listed and separated by what? Commas. Okay, and are enclosed within the brackets. Bracket means you are going to enclosed within a flower bracket, and all the elements are separated by a comma. That is going to be known as the rule form, or the you are going to known as tabular form or roster form. Understood? Roster or a tabular form is nothing but all the elements are written in a brackets. That too it is written with a separated commas. So for example, here I have taken the set of all even numbers between 0 and 10. See, between 0 and 10 means what are all the set of all even numbers? 1 is not a even number, 2, 4, 3 is not a even number, 6, 8 and 10. Correct? So between 0 and 10 only these many. 0 and 10 not equal to 10. Okay, so therefore these are all the numbers you are going to get it as 2, 4, 6, 8. Even though 10 is a even number, but between 0 and 10 we are mentioning that one, so you are going to write within 10 only, not equal to 10. Got? So these are what is that, elements or the objects you are going to write, and within the flower bracket it is separated. This is going to be known as the roster form or tabular form. Then what do you mean by the set builder? Ulta of the set builder, it is nothing but ulta of the roster is nothing but the set builder form. That means the set will be given in a roster form separated by a commas. You are going to convert that into a sentence form, meaning you are going to give for that what is that, the elements. Okay, let us see the example here and let us know the definition of the set builder form. See, in this method all the elements of a set possesses single common property. That means you are going to give the meaning for those elements, and then which is not possessed by any element outside the set. That means whatever you are giving the definition, whatever you are telling for that set, it will be having the same meaning, or it will convey the same meaning whatever within the set only, not outside the set. It will convey the message. Within the set only it will be conveying the message. That is going to be known as what? The set builder form. Okay, so what is the example? See here, 1, 2, 3, 4, 5. I have taken it as only 5 numbers. So then the set builder form can be represented as, see here, A is equal to what is 1? 1 will be starting from, you know already, natural number, isn't it? So I have taken A will be is equal to X such that. So you are going to read it. A will be is equal to, open the flower bracket, X such that X belongs to natural number. The same thing. See, X belongs to natural number, but natural number are infinite natural number. But what we are going taken as here, till 5 only. So lesser than 6 or lesser than or equal to 5, you can write it as. Okay, that is also meaning. Here I have taken it as what? X belongs to natural number and X is lesser than 6. Or you can write it as A will be is equal to X belongs to natural number where X is lesser than or equal to 5. You are going to, natural number will start from 1, 2, 3, 4, 5. Either this definition of a set builder form is okay, or this definition will be also okay for you. Understood, dear students? This is how. So therefore, all the elements will be written in a commas within the flower bracket. All the objects that you are going to give a meaningful sentence for that, but not outside the set. Within the set only you are going to give the definition of that one. That is going to be known as what? Set builder form. Understood? We'll move on to the problems, how we are going to convert. See, represent the following sets in both roster form and then rule form. So set of even natural numbers less than 30. So how we are going to write? You are going to give the set as, always dear students, set is represented by the capital letters. Okay, so you are going to write the set, any one set, that is A I am writing, and within the flower bracket I am going to write it as, this is what the roster form. You are going to have all even natural numbers less than 30. Even natural numbers means you are going to have 2, 4, 6, and then 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. 30 will be not there because lesser than 30, lesser than or equal to 30 means 30 will belongs to the set. This is going to be known as the roster form. Now how the set builder form, dear students? Set builder form will be what? A will be is equals to, you are going to have X such that X is equals to 2n, because multiples of 2 is nothing but the natural numbers. Multiples of 2 is natural numbers where n belongs to natural number and n should be lesser than, what is that? Lesser than, if you multiply 2 1s are 2 2s are 2, 3s are 2 4s are 2 5s are, correct, 2 6s are 2 7s are, up to where it will go? This will go 2 1s are 2, 2 4s are 8, 14. So lesser than or equal to 14 elements, because 14 2s are is 28. You are going to have it as. Understood? This is a condition and this is going to be known as the set builder form. Understood, dears? We'll be moving on to the next problem. Set of all integers between -3 and +3. How we are going to have in roster form? You are going to have, I am going to take it as set B. That is nothing but set of all integers. Integers means all positive integers and then negative integers between -3 and 3. If you write it as in a real form, this is 0, 1, 2, 3, 4, it will continue as well up to infinity, isn't it? This will be -1, -2, -3, -4 up to -infinity. So if you are having there between -3 and +3, you can consider between -3 or not equal to -3 and +3. So what are all the elements you are getting? -2, -1, 0, 1 and 2. So that are all the elements you are going to write. -2, -1, 0, 1 and then 2. If they included -3 and +3, you are going to write -3, +3 here. Understood? This is what? The roster form. Then how the set builder form it will be? Set builder form you are going to write it as set B is equals to Set B is equals to, you are going to write it as what? Set of all integers, isn't it? Integer means x such that, okay, x will be in between, x will be greater than minus 3, see, greater than minus 3, but lesser than what? Plus 3. Plus 3, and x belongs to where? Set of all integers. Integers is represented by z. This is going to be known as your set builder form. Understood? This is how we are going to write this set builder form. Next, we'll be moving on to set of prime numbers lesser than 20. So what are the prime numbers you are having lesser than 20? Let me write it as set C will be is equal to prime numbers. Only the even prime number is nothing but 2. So therefore, and next all between will be odd prime number. 2, 3, 5. What do you mean by a prime number? Prime number which is divisible by only 1 and itself is going to be known as the prime number. So 2 is divisible by only 1 and itself. 3 is also divisible by 1 and itself. 5 is divisible by 1 and itself. And then 7 is divisible by 1 and itself. 9, it is a composite number. And then you are going to have it as 10, it is a composite 11. Correct? And then 12 is a composite 13. And then you are going to have it as 15, it is not a prime, it is a composite. 16 is a composite. 17 you are going to have it as, isn't it? 17, and then 19. So these are all the prime numbers you are going to have it as lesser than 20. So how many prime numbers are there? 1, 2, 3, 4, 5, 6, 7, 8 prime numbers are there lesser than 20. Understood? How we are going to write it in a set builder form? Set builder form can be written as, how it is will be equal to, C will be is equal to, set C will be is equal to, C, x such that x is a prime, same you are going to write less than 20. That's it. This is easy, dear students. Yes, it is easy, right? The same sentence you are going to repeat it in the set builder. It should give the meaning within the set itself. Understood? Next, we'll be moving on to the next topic, which is nothing but convert the following sets from the roster form to a rule form. You are going to convert the roster form, that is tabular form, to a set builder form. Understood? How we are going to convert? They have given already in the, what is that? In the roster form, you are going to write it in the rule form. Already told you 4, 8, 12. If you see, it is a multiples of 4 only. Therefore, you can write it as set A. Already they have given, defined it as set A. I am going to take it as same set will be is equal to x such that x is equal to 4n. Correct? Where n belongs to what? N belongs to set of all natural numbers. Why? It is starting from only the 4, not minus 4, minus 8 you are going to have. 4, 8 will be a positive. Positive numbers, this belongs to the natural number. This is what the rule form you are going to have it as. Understood? Next, June, July. What are the June, July? Especially June, July is a month which is starting from the letter J in a year. Correct? So therefore, we are going to write it as set E will be is equal to x such that x is a month of the year. Month of the year starting with letter J. June, July. Starting with letter J. That's it. That is called set builder form. It will, the sentence meaning, it will not go beyond the set, whatever they have defined the elements, isn't it? Next, A, B, C, D. What are all A, B, C, D? A, B, C, D are the letters. What letters? First 4 letters of what? A, B, C, D belongs to alphabets. That is what you are going to write the sentence. What is that? So, C will be is equal to X such that X is an first 4 letter of the alphabet. First 4 letter of alphabet. What is that X? X is a what? It will be a general element. We are going to have it as alphabet. Understood? Is that so easy, dear students? Whatever you are going to define the sentence, you should not go beyond the meaning of whatever the given elements. That's it. Understood? We'll move on. The next is nothing but convert the following from rule to roster. Rule to roster means they will be given in a sentence. You are going to write it in a separated commas, the elements, isn't it? So you are going to have it as X. X is a letter. In the word engineering, dear students, engineering means you may write it like this. E comma N, comma G, comma I, comma E. Dear students, whatever the repeated letters within the set, you are going to write it only one time. That you have to remember, whatever the repeated letter, if you want to write that one in a roster form, you are going to write that letter or the number only once if it is repeated. So therefore, you are going to write it here. A will be is equal to, what all? E is there, N is there, G, I is there, N is already written, E is already written, R. R is there, G already written. So therefore, the letters are E, comma, N, comma, G, comma, I, comma, R. That's it. The repeated letters, you are going to write it only one time. So this is going to be known as the, what is that? Roster form for the letter. They may give it as like this also. What is the letter of the letter in the word school? So school means you are going to write what will be the school? You are going to write it as B will be is equal to S, C, H. O is repeated two times. So you are going to write only one time. Or college, if you take it as, if I am going to write the college will be is equal to word college. How we are going to write it as? Set C will be is equal to C, O, L repeated twice only one time. And then E also, O you are going to write it as college. E is repeated twice only one time. And then G. Understood? This is how you are going to write it as. When the word is given with a repeated letter only one time, you are going to write inside the set. Understood? The element. Each it is going to be known as the element or the member or the object. Okay. Next they have given B is equal to N squared minus 7N plus 12 equal to 0. What is this, ma'am? Quadratic equation, dears. How to solve the quadratic equation? We know already the quadratic equation can be solved. N squared minus 7N plus 12 equal to 0. If you multiply, you should get what? 12N squared. If you add or subtract, you should get what? 7N. That too minus 7N. What are all the roots? Minus 4, minus 3. Minus 4N into minus 3N is plus 12N squared. Minus 3N minus 4N is nothing but minus 7N. So therefore, you are going to have N squared minus 3N minus 4N plus 12 will be equal to 0. I'm not writing the set, I'm solving and then I have to write the set here, okay? So then you are going to common take N minus 3 minus 4 into N minus 3 will be is equal to 0, and then N minus 3 if you take common, N minus 4 will be remaining, will be equal to 0, or N minus 3 equal to 0, N minus 4 equal to 0, N equal to 3 or N equal to 4, but you are going to write all the elements under the set. Therefore, if it is repeated, same roots, it will be written only one time, but quadratic equation will be having two roots only. Here we are getting two roots as the 3 and 4. Sometimes you are going to get the two roots as one is positive and one is negative, like that. So therefore your B set will be is equal to writing all the elements separated by a comma, 3 and 4 all the elements we are getting. This is a roster form. Is that easier, dear students? Okay. Suppose if you are giving it as cubic equation, you are going to solve cubic. 3 roots will be getting for the cubic. Okay. Next we'll be moving on to types of sets. Null set or empty set. What do you mean by a null set? Means nothing is there within the set is going to be known as the null set. Okay. So here a set containing no element at all. No element. There is no element inside the set. How you are going to represent then set? So set you are going to represent it as a phi, or you are going to write it in flower bracket. That is a symbol. You are going to write it as empty set or the null set. Okay, in 2000, we are going to write it as 2021 trending. The President of India was a woman. It cannot be? No. So it is the person, man. It is a person, isn't it? So therefore, it is a empty set. You can take it as an example. Now, the mathematics example I am giving here. The set of all even prime number other than 2. Which is a even prime number other than 2? There is no prime number other than 2. All are odd numbers only. Therefore, you are going to have that is a null set. Understood? So, other example. The set of all natural numbers lesser than 0. How? Set of all natural numbers will start from 1. So, there cannot be natural numbers lesser than 0. That is going to be known as the null set. This is a mathematic example. What I have given the precedent, it was a real-time example, dears. Okay. So, next you are going to have it as what is 5 or what is that? 2 you are going to, not to here. This is nothing but a phi or this one. Singleton set. Singleton means what, dears? Singleton means you are going to have only one element. Inside the set you are going to have only one element. That is going to be known as singleton. Meaning itself says single means one element. Okay. So therefore set containing only one element is going to be known as the singleton set. For example, I have taken here equation x minus 1 equal to 0. X belongs to n. Okay, the president of India was same example you can take it as, isn't it? Only one president of India. There cannot be two presidents. It is a singleton set, isn't it, dears? Okay, here I have taken x such that x minus 1 equal to 0. Which form it is, dears? It is in the form of roster, isn't it? Set builder form. It is in the form of a meaningful sentence. You are going to have it as. So therefore, you are going to have A will be is equal to only one element inside the flower bracket. You are going to write it as. Is that easy, dears? Okay, we'll move on to the next. What is the types of set? Finite and infinite. The meaning itself says finite means it can be countable. It is going to be known as the finite. Infinite means which cannot be counted. It is going to be known as the infinite sets. Therefore, finite set is nothing but set is called a finite set. It contains finite number of elements. That means you can count the elements. Okay, that is going to be known as the finite set which cannot be counted, infinite. So here I have taken an example. A is equal to 1, 2, 3. It can be counted. There are three elements. Okay, so n of a, always elements are represented by n of a. N of a means number of a. Number of a means number of the elements inside the set A. Understood? There are three elements. If I am going to take it as A, B, C, D, how many elements are there? This is a set B. So therefore, n of B will be known as 4 elements. Okay, there are 4 elements inside the set B. That is an example. Here you can take it as the set of natural numbers. Okay, the set of real numbers. What are those? The set of natural numbers are infinite. The set of real numbers are infinite. So this is an example of the infinite set. Therefore, here I have taken the set which is not finite is going to be known as infinite. This is an examples of infinite set. The set of all natural numbers, the set of all real numbers, the set of all integers, all are going to be known as the infinite. The set of stars on the sky, can you count the stars on the sky? No. If you sit and count, it cannot be. So it is also called as a infinite set. Understood? Sun is a star. As there is only one sun in the world you are going to have, it is a singleton set, isn't it? But that is also a star. Okay. So next we are going to have equal sets. Don't get confused in the equal set and equivalent. Next it will come. Equal set means, understood here, A and B, to define an equal sets, we are going to take it as set A and set B. Okay. So set A will be having the number of elements. If there are 3 elements in set A, 3 elements will be set B only, but same number. If you are having here A, B, C, you should have here A, B, C also, but different order. Order can be different, but same number of elements should be present in both set A and set B is going to be known as the equal sets. So the definition is two sets are said to be A and B to be equal if they have exactly same elements. This is very important. If they have exactly same elements. For example, here you can take, see, A is equal to 1, 2, 3. Same I have taken A is equal to 8, 3, 1. See, 8 is present here, 8 is. 3 is present here, 3 is. 1 is present here, 1 is. How many elements are there? 3. How many elements are there? 3. Okay. So same number of elements, same elements. It is going to be known as the equal sets. Okay. For example, if you are having, what is a non-equal means? Set A is equal to A, B, C. And set B is equal to C, D, F. This is a equal? No. Not equal. Why? Because obviously n of A is 3. N of B is also 3. You are having same. Okay. But what is n of A? A, B, C. N of B, C, D, F. They are not equal. Isn't it? So therefore it is an unequal set. Understood? Equal means same element should be present. Any order can be it is. Same number of elements and same elements. Okay, exactly same. Next you are going to have it as the example. X is a letter in the word flow. See? Flow. X is a letter in the word wolf. See, wolf, you are going to have it as what? Flow, wolf. You are going to have same element. Though the letter L is nothing but silent here, but you are going to have same number of letters. But the order can be changed here. So this is going to be known as the equal sets. Okay. So then A is equal to B. We are going to write A and B have the same elements. Understood? This is how symbolically we are going to write it as. Got? Next we'll be moving on to the equivalent set. What do you mean by equivalent set, dears? Two finite set, it should be a finite means countable. Two finite set A and B are said to be equivalent if they have same cardinal number. What do you mean by a cardinal number? Cardinal number means number of elements in a set is going to be known as this cardinal number. I'll give you the definition exactly afterwards. Okay. So here same number of elements. You are going to have the number of elements in the set is going to be known as the cardinal number if the same number of elements are present here. That's it. The meaning I've taken. What is that? If n of A is equal to n of B, cardinal number is represented by number of elements in set A, number of elements in set B. They are equal means any two number of elements in set A. Whatever the elements are, you are not going to consider or you are not going to see whether same elements are present, but you are going to see same number of elements are present. It is going to be known as the equivalent set. So for example, here I have taken what is that? A, E, I, O, U. What is that? A, E, O, vowels, correct? And then 1, 2, 3, 4, 5. What is 1, 2, 3, 4, 5? It is a letter. Sorry, it is a, you are going to have it as numbers. This is the letters. So letters, but how many? 1, 2, 3, 4, 5. Here 1, 2, 3, 4, 5. So how many numbers are present? N of A is equal to 5 is also equal to n of B. Whatever the elements, you are not going to worry about that. You are going to worry about the number of elements. How many number of elements are there inside the set A and B? That is going to be known as the equivalent set. Therefore, n of A is equal to 5 and n of B is also is equal to 5 here. Understood? Well, you understood between the equal and equivalent. Equal means same elements, same number of elements. Equivalent means not element, whatever the elements are present there, you are not going to worry, but same number of elements must be there. Okay. So next, subset. What do you mean by a subset? There are two sets you are going to take it as. Subset means if each and every element of A is an element of B. Suppose if I am going to take it as A is equal to, see here I have taken 1, 2 and B is equals to 1, 2 and B is equal to what? 1, 2, 3, 4. Okay. See, 1, 2 is present in B. Therefore, A is in B. That is going to be every element, each and every element of A, that is set A, is an element of or is present in set B. That is going to be known as the set A is a subset of B. Suppose ulta if it is every element of B, that is, for example, if B will be is equal to AB and A will be is equal to ABCD. See, B is a subset of A because every element of B is present in A. That's it. So B is a subset of A in this case. In this case, A is a subset of B because every element of A is present in B. That's it. Okay. So therefore, we are going to write symbolically like this. A is a subset of B. Understood? We'll be moving on to the next. Note, if at least one element of A does not belongs to any element of one element of A also does not belong to any element, one element. Suppose if you are having like this, suppose A is equal to 1, 2 and B is equal to 1, 3, 4. See, 1 is present but 2 is not there. Every element should be present. Then only it is going to be known as A is a subset of B. Otherwise, A is not a subset of B. A is not a subset of B means it is symbolically represented like this. Okay. Now, every set A is a subset of itself. Every set A is a subset to itself only. You are going to have it as, we are going to write it as A is a subset of A. And then phi is subset of every set. Phi means empty set. Empty set is a subset of all the sets. Empty set is a subset of A, subset of B, subset of empty set, subset of singleton set. Okay. Empty set will be a common, that is a mandatory. You are going to have it as. So if A contained in B, B contained in A, if A is a subset of B, B is a subset of A, then A will be is equal to B. Okay. A is contained in B and B is a, suppose for example, set of all natural numbers in a set of all whole numbers, subset of, correct na? Because natural numbers will start from 1, whole numbers will start from 0, set of all natural numbers is present in set of all whole numbers. That is going to be, and set of all whole numbers except 0 is present in natural numbers except 0. It cannot be a both equal. It will be only the subset. Okay. Next we'll be moving on to the right all the possible subset of the following. How we are going to write the subsets of the following? Dear students, be careful. You have to observe here what are all the subset. First you are going to consider 1 element. Then you are going to consider 2 element. Then you are going to consider all the 3 elements. Understood? So here we are going to have it as A will be is equal to subset or 1 element. You are going to write it as singleton, and then you are going to have it as 2, and then you are going to have it as 3, and then you are going to have it as 1 2. These two 1 2, and then 2 3, and then you are going to have 3 1, and then you are going to have 1 2 3. Correct? And then you are going to have it as 5. These are all going to be flower bracket. Within flower bracket only you are going to write, see, I have closed the flower bracket. Within flower bracket only all the subsets you are going to write it as. Okay. These are going to be known as the subsets of the given set of elements. What are the subsets of B then? First you are going to write, see, 5 is a common. Set B will be is equal to, first write all the elements, then you can put the flower bracket afterwards. Otherwise you will get confused. Okay, 5 is an element, then single set, that is A, and then B, and then you are going to have A comma B. That's it, correct? So therefore, this is how we are going to write the flower bracket afterwards. 1 2 3 4. How we are going to write this one as, ma'am? That is nothing but the power sets. You are going to write it as 2 power n elements will be there. How that will be defined? Next you will come to know. So what will be a power set of that one? All you are writing. See, first you are going to write single, and then you are going to write the double, and then you are going to write whatever it is the elements are there. Next, see here only 2 elements, till 2 orders only we are going to write it as. Understood? Next we'll be moving on to the superset. What do you mean by superset? Set A and set B are 2 non-empty set. It cannot be empty. Okay, that means it cannot be a null set, such that A is contained in B and A not equal to B. That means A will be present in B, okay, but A will be not equal to B. That is going to be known as the superset. How we are going to define the superset? See, then B is called the superset of A. It is symbolically represented like this. B is called superset of A. For example, see, set of complex numbers is a superset of real numbers. Why? Complex number not present in real number. See, real number does not include complex number. Complex number is presented as C, but in the complex number means C is equal to A plus IB, or Z is equal to, right? See, Z is equal to A plus IB. What is this A and B? A and B both are present in real numbers. A and B are there in real numbers, but complex number will not be there in the real numbers. So set of A is a real number, set of B is a complex number, set of A not equal to set of B, but B is contained in A, correct? Real numbers A and B of a complex number are there in the real number. Therefore, complex number is a superset of real numbers. That's what complex number is a superset of the real numbers. Okay. Next we'll be moving on to proper subsets. What are the proper subset? What are the elements you are going to write in the subset will be not equal to the, what is that? The superset you are going to, will be not equal to the proper set. They are not equal. That meaning I am going to convey you yes here. A is called the proper subset of a B if each and every element of A is contained in B and A not equal to B. Each and every element of a set will be there, but subset will be not equal to the elements of the superset. That is going to be known as the, what is that? Proper subset. Okay. So here it's a symbolically represented. A is a proper set of B. Subset means like this. A is a subset of B. This is a subset. Okay. This is proper set, and it is written as A is a proper set of B. Understood? Next we'll be moving on to power set. What do you mean by power set? Power set means a set formed by all the subset of a set. That means whatever the subsets you are writing, the set formed by that itself is the power set. For example, here we have taken, see what we have written here. We have written all the subsets. See, the set formed by all the subsets. How many sets are there? If there are 3 elements, power set of A will be 2 power n elements. 2 power n means how many numbers are there in the set A. So 2 power n means 2 power how many? 3. So 3 means it will be equal to 8. So 8 elements or 8 objects should be present in the subset. That is going to be known as the power set. Here how many? 2 power 3 means 8. 1, 2, 3, 4, 5, 6, 7, 8. There are 8. So here there are 2 elements. 2 power 2. 2 power 2 means 4. There should be 4 elements. That is 1, 2, 3, 4. That's it. That is going to be known as the power set. Power set means what? It is all the, what is that? The number of all the subsets. Okay, you are going to have it as that is going to be known as the power set. So here we are going to have it as the power set is nothing but set formed by all the subsets is going to be known as the power set, and this is denoted by P of A. Okay. Then what is the set A, B will be having? The subsets will be A, B, and then AB, not AB, you are going to have it as 5. Okay, that's it. And then P of A will be is equal to this one. What is that? P of A, 5A, AB, and then you are going to write in the flower bracket. That's it. So number of P of A will be is equal to 2 squared, as you said, is equal to 4. If it is there 4 elements, for example, A, B, C, D, and then you are going to have 2 power 4, which will be 16 subsets will be there in the power set. Understood? Next we'll be moving on to the note. What is a note? You are going to have n of P of A is 2 power n. Number of power set of A is nothing but 2 power n, where n belongs to what? It is the number of elements of a set A, number of elements of set B, number of how many elements are there in the given set? That is n. Okay. So here if A is equal to 5, 6, 7, 5, P of A. What is a P of A? Let me write it is here. Number of P of A. So subsets. Let me write the subset first. Subsets will be is equal to what? Subsets of A. What is that? 5, 6, 7 will be is equal to P of A will be is equal to 2 power 3, which will be 8. Correct? 8 numbers should be present here. 5, 6, 7, and then 5, 6. And then you are going to have 6, 7, and then you are going to have 7 and 5, and then 5, 1, 2, 3, 4, 5, 6, 7. One more is 5, 6, 7. That's it. This is going to be known as a power set. Number will be 8. That's it. Now, if A has 4 elements, how many elements will be having power of A? How many elements? If A is what is that? Number of elements are 4. What will be P of A? P of A will be is equal to 2 power n. 2 power n will be how many elements? 2 power 4 will be is equal to 16 elements will be present inside the power set of A. Okay. Next we'll be moving on to the, if A is equal to 2, 3, 4, write all the proper subsets of A. Proper subset means what? Proper subset means set A will be the element of set B, but A not equal to B. A will be not equal to subsets. Okay. That is going to be known as a proper subset. Okay. So proper subset, first let me write the subset and then I'm going to write the proper subset. Okay. So here you are going to have subsets of A. Subsets of A will be is equal to, what is that? 5 can be written as flower bracket or 5, and then you are going to have it as 2, 3, 4, and then 5. No 5. So 2, 3, and then you are going to have 3, 4, and then 4, 2, and then you are going to 1. So how many? 2 power 3 means 8. 1, 2, 3, 4, 5, 6, 7, 8. That is 2, 3, 4. So what are the proper subsets? Proper subsets are only these. Proper subsets. Proper subsets of A will be is equal to 5, 2, 3, 4, 2, 3, 3, 4, 1, 2. That's it. This is going to be known as, see, proper subset will not be equal to the subset. This element will be not there. One element will be lesser than that one. Okay. That is going to be known as the proper subset. Understood? It will be not repeated once again. Right? So next let us move on to the universal set. Universal set means set of all you are going to have. Universal set for all the states is nothing but the India. India will be present here. The whole world will be having here the population like that. So here, set of all people, if you take it as the whole world, it will be the universal set, isn't it? Anywhere you can take it as. So here, if all the sets under the consideration are subsets, all the sets under the consideration or of a subsets is going to be known as the universal set. Universal set is always represented by U. For example, here I am going to take it as, see, this is it is represented by like this. And then here, for example, for the set of integers, what you can take, the universal set is nothing but set of all real numbers. Set of whole numbers, the set of all, what is that? Real numbers is also a universal set. Okay, set of rational and irrational, the universal set is real number only. So all the set of numbers is nothing but the real only. Universal set, we are going to name it as real number itself. That you have to remember. Universal set under the number system is real number only. Got? So next you are going to have cardinal number. I told you. Cardinal number means what? The set of all numbers present in the set of all elements, or the members or the objects present in the given set is going to be known as a cardinal number. Cardinal number is going to be defined by n of a. It is denoted by n of a. So here, cardinal number of a finite set, not infinite, finite set. Here, the number of elements of a finite set A is called the cardinal number and is represented by n of a or n of b, n of c, n of d, like that. Whatever the set is given, that number of elements you are going to write it as cardinal number. For example, here I have taken 1, 2, 3, 4, 5, 6. The cardinal number, how many numbers are there? 1, 2, 3, 4, 5, 6 numbers are there. So n of a, we are going to write it as 6. If there are 4, 4. If there are n number of elements here, it should be a finite. Understood? Any doubt do you have in this session? I think you've understood this session, how we are going to have it as. So dear students, these are all the basics you are going to have under the sets and the types of set, how you are going to have it as power set. This can be asked for your 1 marker for your examination. So thank you dear students. In the next section, we'll be moving on to some more problems of the relations explanation. Understood? And also, what do you mean by the relation? What do you mean by the function? All that we'll be studying in the next sessions. Thank you dear students.